So, the last three fractional equations in this exercise. And so, for example, in the first one, the important thing to see here is to always find the least or the simplest common denominator. So don't just multiply these things together. You will get a horrendous polynomial, especially if you expand it in the denominator, then you will have no chance of simplifying the fraction. We need to be on the lookout for factors. So we factor r squared plus 4r and see that we actually get lots of factors that are also present in the other fractions. So we just have three distinct factors, r plus 4, and 4. So the common denominator, the simplest common denominator is to just multiply all these together. So we expand all the fractions to this common denominator. So there's a factor of 4 missing in the first fraction. In the second, there's a factor of 4 and r missing. And in the third one, we need an r plus 4. And well, the common denominator is always the same. So I wrote down the common denominator like this in every fraction, but well, there's no real need because now we multiply out the common denominator anyway. So I can just take this and this is very satisfying to just erase the denominators. And we are left with a polynomial equation, or just a linear equation even. So that's easy to solve. Before we do that, of course, we never looked at the domain. The domain is anything except 0 and minus 4. So should we get 0 or minus 4 as a solution here, we need to discard it. 12r plus 28 minus 20r equals r plus 4. We want to get the r on the left-hand side and the 28 on the right-hand side. So we get 12r minus 20r minus r, that's minus 9r. And we get 4 minus 28, that's minus 24. We divide out minus 9. And we can reduce to 8/3, which is in the domain. So the set of solutions has a single solution 8/3. Number H. Now this looks complicated, but again, just look for common factors. Look for factors in the denominators. This is a binomial formula for x minus 3 squared. And look, what a coincidence, we have x minus 3 also in the second fraction. We have no fraction on the right-hand side, but, well, we just make us one, because we want a denominator of x minus 3 squared also here. That means we need an extra factor of x minus 3 in here, in this fraction. And now we already have three fractions with the same denominator, which we can multiply out. We can multiply out because we know that whatever we multiply onto our equation can't be 0, because this is the domain. And let's also put this on the left-hand side, because we want to be able to apply the zero product rule. What do we have? X plus 6. Here we have x squared minus 8x plus 15. and here it's x squared minus 6x plus 9. And there's a little bracket to open here. Now what do we see? X squared and minus x squared. These reduce. And we just have a linear equation. What do we have? We have, let's collect some like terms. We have an x, we have an 8x and a minus 6x. That is 3x. And we have a 6 and a minus 15 and 9. That's 0. So 3x equals 0, x equals 0, which is in the domain. So we get this in the solution 0. And finally, the last equation is almost identical. There's just a 2 instead of a 5. And so we can actually take all this calculation and just make little changes to it. So let's see. So x minus 5 is actually x minus 2. The domain, the common denominator, all that doesn't change. What changes is that this now is plus 5x and minus 15 is minus 6. So how many x's do we have? X plus 5x minus 6x is 0x. And what kind of constant terms do we have? 6 minus 6 plus 9, that is 9. So 9 equals 0, that is impossible. So no solutions.